Are we alone in the universe? It's a question that has captivated humanity for centuries. But maybe the better question is, are we destined to stay on this one beautiful blue marble forever? The answer, I believe, is a resounding no. Our journey to the stars is not just a dream. It's becoming a tangible reality. And today, we're diving deep into how we can build a future for humanity beyond Earth. So, let's get the big challenges out of the way first. Deep space is not exactly a friendly neighborhood. Two of the biggest hurdles we face are radiation and the effects of microgravity. Outside the protective bubble of Earth's magnetic field, we're exposed to a constant barrage of cosmic rays and solar radiation. It's like standing in a non-stop, high-energy particle shower. Over time, this exposure can wreak havoc on our health. Astronauts on the International Space Station already face this. But a trip to Mars or beyond would mean much higher doses. Then there's microgravity. It might look fun to float around, but living without gravity takes a serious toll on the human body. Our bones lose density, our muscles atrophy, and even our cardiovascular system gets lazy. It's like your body forgets how to work against resistance. If we're going to live and work in space for years, or even generations, we need to solve these fundamental problems. So, how do we do it? Well, we're not planning on sending people out with just a spacesuit and a wrench. The future of space construction and exploration will be heavily reliant on our robotic friends. Imagine fleets of autonomous robots, working tirelessly to build habitats on the Moon or Mars before the first human even sets foot there. These robots would be the pioneers, the advanced team laying the groundwork for our arrival. They could 3D print entire structures using local materials like Martian regolith, which is basically the soil on Mars. This is a game changer. Instead of launching every single brick and beam from Earth, which is incredibly expensive, we could use what's already there. These robots could also handle the dangerous stuff, like deploying solar panels, assembling heavy equipment, and performing routine maintenance in the harsh vacuum of space. They wouldn't get tired, they don't need to breathe, and they can withstand radiation levels that would be harmful to humans. By letting robots do the heavy lifting, we make missions safer and more efficient. Now, building a house is one thing, but how do you sustain a whole community off-planet? You can't just order groceries online. This is where another revolutionary idea comes in. Living off the land, or more accurately, living off the asteroid. Asteroids are not just boring space rocks. They are flying treasure chests of resources. Many of them are packed with water, precious metals like platinum and gold, and other vital elements. Think about it. Water is the key to life. You can drink it, you can use it to grow food, and you can even split it into hydrogen and oxygen to create breathable air and rocket fuel. If we can capture an asteroid or mine it in place, we could create a self-sustaining refueling station in space. This would be like building a gas station in the middle of the desert, opening up the entire solar system for exploration. We wouldn't have to carry all our fuel with us from Earth, which is one of the biggest limitations of space travel today. This concept, known as in situ resource utilization, or ISRU, is the cornerstone of long-term sustainability. All of this points towards a future where we create permanent, self-sufficient outposts beyond Earth. Let's talk about the big picture strategies. First, we need to accelerate our technology. We're talking about revolutionary new propulsion systems that can get us to Mars in weeks instead of months. Think fusion rockets or solar electric propulsion. We also need to build the infrastructure. The space stations, the mining depots, and the interplanetary communication networks. This is the Highways and Bridges project for the solar system. Second, life support has to be sustainable. On Earth, we live in a closed-loop system where nature recycles everything. We need to create our own miniature high-tech versions of that for our space habitats. Systems that can recycle 99% of our air and water and grow fresh food in advanced hydroponic or aeroponic farms. The goal is to be completely independent from Earth for our basic needs. This not only makes long-duration missions possible, but also teaches valuable lessons about sustainability that we can apply right here on our home planet. And third, as we've discussed, resource management is key. We need to get really good at prospecting for resources. Whether it's water ice in the shadowed craters of the moon or valuable minerals on a near-Earth asteroid, mastering ISRU will transform our approach to space exploration from short, expensive sprints into a marathon of sustainable settlement and discovery. It's an incredibly ambitious vision, but every great leap for humanity started as just that, a vision. We are at a pivotal moment in history. The technologies we are developing today are the building blocks for humanity's multiplanetary future. This isn't about escaping Earth. It's about expanding our horizons, ensuring the long-term survival of our species, and embracing our innate drive to explore the unknown. The journey will be challenging, full of risks and setbacks. But the potential reward is a future that's grander than we can even imagine. The stars are calling, and we are finally learning how to answer. Thanks for watching and exploring this incredible future with me. If you're as excited about space exploration as I am, make sure to hit that like button and subscribe for more deep dives into science and technology. See you in the next one.